Hello, everyone. Welcome to today's webinar on interest rates with Python, converting between different compounding frequencies. My name is Alexandre Landi. I will be your host for this session, and I am in the delightful company of Jianan Chen, or Joël Chen. Welcome, Jojo.
Hi everyone. Thank you for having me, Alex.
Yeah,
it's gonna be fun to have this session together.
Yes, it is a delight to have you. So let's start with why you have multiple names, because your real Chinese name is Jiannan, but there's an interesting custom, right, for Chinese people to, when they come to the West, they take on a name that sounds more like Western. Is that correct?
Yeah. I mean, it's a quite common practice for most of us. I mean, that's mainly because in general we find like you guys might have difficulty in pronouncing our names properly. So just to make everyone's life easier, so we invented we actually tried to bring a Western name for us.
Yeah. And so the one that you chose when you came to France to study at Schema Business School back in 2013, 2014 was Joël.
Yes, that's right.
And since then, you have become Jojo for your friends.
Yes. I do like it.
I do like it too. So Joël and I were classmates at Schema Business School in 2013 and 2014. We were very unlikely candidates for the Master of Science in Financial Markets and Investments. Both of us had humanities background, and when I came to Schema Business School and I was I had my humanities background, I thought I was the only one, and I'm pretty sure you thought that too.
Well, I didn't think that I didn't think through. I mean, I was just like, I was selected, and okay, fine, I'll just go for it.
Let's go for it.
It was a bit pressure in the very beginning to start the master, but yeah, it took some time to get used to, and especially when you see people around you are mostly with some sort of related background, and it did look easier for them to catch up. So you have to put more efforts on to keep the pace.
That's right. That's true. We worked a lot together. We spent lots of hours on the board doing exercises and trying to derive formulas, trying to understand where those formulas were coming from. That was a very good time. So today we will be talking about interest rates. So it's a relatively foundational topic, and we'll see how to apply it in Python. And this is part of the program of the class of students from the Programme Grande École for the first year of master, who are aiming at then becoming graduates of the Financial Markets and Investments program at Schema Business School. So we will put together notions from finance and from programming. And I'm so happy that I am in the company of Joël. And why don't we start with a little bit of some exercise, which I am going to copy and paste here. There we go. There we go. Joël, would you like to read the exercise for us?
Yeah. So a bank quotes an interest rate of 7% per annum with quarterly compounding. So what is the equivalent rate if it's annual compounding or it's a continuous compounding?
Okay. So if we were some very bad teachers, we would throw the formula on the head of our students, just like
or maybe just
they,
a Wikipedia link.
yeah. So I suggest to start with the formula, and then we will see how we get there. What do you think?
Sure. I mean,
so can you help me?
Yeah, it's quite trivial to actually see. So suppose it's just purely annual, then you actually start with 1 plus the R, which is an interest rate, right?
Yeah.
Suppose.
So let me just start with the final formula, and then we'll derive it. So the thing is that we have this RA, which is the annualized rate, and the way we compute that is that we take 1 plus RQ, so the quarterly rate, because this is what we're getting, divided by the frequency. So that's, that's the number.
Fourth a year, yeah, in this case.
Right. So the number of compounded periods per year, and then we subtract 1 to that. And so let me just make it a little bit clear what all of it is. So RA is the annualized rate, and this guy RQ is the quarterly rate. We're
missing the squared m. So I mean, it's it's compounded. Right. So yeah.
It reminds me of when you told me that if I ever had children, I would forget them somewhere. Do you remember?
Yeah, I do.
I would always forget some sign here and there. And then M is the number of compounding periods. And so, which in this case, can you remind me what is RA? So the annualized rate is
7.
That's the annualized rate. This is RA.
7%. Yeah.
So that's 7%. And then there's the quarterly rate, which is the one that we
try to solve.
We try to solve for. Oh, wait. No. I just said, this is not RA, this is RQ. This is the quarterly rate. And we're trying to solve for RA.
Yeah, that's right.
So this is the one that we don't know. And this is the one that we know. And the number of compounded periods, since it's quarterly compounding, so how many quarters in a year?
4 quarters, so it's 4.
4 quarters per year. All right. So this is how one computes that. However, maybe someone would be curious to know where the heck this formula comes from, rather than dropping it on our students' head. Do you think? Could you help us derive a little bit this formula? I mean, where does it come from?
So you can actually split in this case, you can split the whole year into 4 periods. So every period it will be 1 plus
Oh, you're breaking up a little bit. Your audio is breaking up.
Yeah.
So
yeah. Go ahead.
You go ahead.
I mean, at the end of Q1, so suppose you have the principal X amount, and at the end of Q1, what would be your interest that you earn? It would be X times parentheses 1 plus RQ over 4, right?
RQ over 4. Yes, so that would be RQ is 7% over 4, and that would be the first quarter, right? And then
yeah, that's like principal plus the interest rate, right? That's
yeah. So is this
and
accurate? Is this what I just wrote here? Is this accurate for the first quarter?
yes.
All right.
And for Q2, you will be getting another 1 plus 7% over 4, right?
That's
And you do the same
correct.
over the 4 periods. So it's basically principal times 1 plus 7% over 4 square. How do we say squared?
To the power of
you
n.
to the power of to the power of 4, right?
To the power of 4, to the fourth power. So this is 7% over 4 to the fourth power. So this is what we would get with the compounding. And what we want to know is what would be
The
the
annual
effective annualized rate. So basically, we have our principal, and we know
times
that
1 plus RA.
yeah. So we know that this guy P times 1 plus 7% over 4 is equal to P times 1 plus our RA, as you were saying. And in this
Yeah,
case,
but sorry, I think you missed the fourth power again on the left.
yes,
On the
thank
left
you.
side. Okay, good. No problem.
You are the reason why I didn't fail my exam, my entire master's. So, and in this case, so M, when A is annual, so M is 1, because there's only one year in 1 year, and so this is to the power of 1. So I mean, I can write them to the power, so over 1 to the power of 1, which is basically doesn't need to be written.
Yeah.
So
So
we have these two guys.
Yeah.
And we need to solve for this guy here, correct?
Right.
So let's do that. And so it seems to me that we can divide both sides by P.
Correct.
So that this guy goes away. So we're left with this guy and this guy. So let me rewrite it so that it looks just a little bit cleaner. We have 1 plus 7% divided by 4 to the power of 4. And then we have 1 plus RA. And then what can I do here? I can subtract both one by both sides, right? So that eventually we have that RA is equal to 1 plus 7% over 4 to the power of 4 minus 1. Did I forget any baby anywhere, Joël?
No, not this time. Good.
All right. So this is how we compute the annual compounding rate, and we might want to do this exercise to code it in Python. And the way we would do that is to set RQ equal to 0.07, and then M, we set it equal to 4, and then we say that RA, would you tell me the formula again, Jojo?
It's 1 plus RQ over N to the power of N minus 1.
power of m, all of which is, yeah.
Well, I mean, well, I'm wondering why don't you actually define a function that and with RQM as the variables, then you can just basically have a function to calculate the annual compounding rate.
I think you're right. I think you're right. The reason you wonder that is that you're smart, and I will definitely do that. So let me just like do it the simple way for now, and let's build a function on that just after this. So
okay,
let's see. I want to print our A, and let's see how much is that. Let's round it so that we don't have countless decimals. So our A, let's round it to 4 decimals. And let's close this and see what happens. String unmatched. There's something. Oh, yes. This is what we wanted. So let's make it a little bit clearer. Is it large enough? I think the code is really small. Is it?
It's relatively small, but it's still readable. So fine.
Let's make it a little bit bigger. A little bit bigger.
That's better.
Okay. So we have an annualized rate, an effective annualized rate of
7.19%. Yeah.
Okay. And what you were suggesting is to create a function, right?
Right.
And what would be the purpose of that?
I mean, then you can simply just. I mean, it's easier. It would be just a function. I mean, it's easier to use rather than replacing the value of RQM every time. You actually you have a function in place, and you just need to put in the values in this variable of this function. And I think it's easier to use, more user friendly.
I think you're right. And basically the way, I mean, what we need as an argument is, I mean, we need to have the nominal rate, and we need also the number of
compounding periods,
which is our m. And what we need to return is the effective annual rate, and the way we compute it is we take this guy and we set it equal to what we just said earlier, which is 1 plus our nominal
over m
over m to the power of m minus 1. And then let's see if it works. Let's print. Let's print. Let's put this in the function. Let's say let's print. So effective annual rate. That's going to be equal to this guy. Effective annual rate. So let's see if it works. I'll execute. Of our nominal, and this our nominal. So the nominal rate is 0.07, right?
Mm-hmm.
And m is still 4. So let's see what we get. All right. Yes, we get the same result. Maybe we will want to round it
as well.
just so that it looks a little bit nicer. Just so it looks a little bit nicer. And up. Voila.
Just a side question, because I mean, it definitely experts on Python right now. What is the reason that we have 3 rows of prints here? I mean,
it's
to my knowledge, one single row should work as well, right? But just try to understand what.
That's correct. So if I comment all the lines and print only one, it just gets a little bit packed.
Oh,
so
okay.
I just wanted to give it a little bit more space so that it is easier to read.
Understood.
Just
understood.
No fancy reason.
No, I thought there was some sort of trick and would just make the function to work more smoothly.
Yeah, no.
I see what you.
I just hated with all my guts when our teachers used to print statements one after the other, and they were all packed together, and I didn't understand which is which.
I agree.
So that is why.
That's a good habit, honestly.
So we did this for our effective annual rate, but then, if I remember correctly, there was another question, which was what is the equivalent rate with continuous compounding? And can you tell me, Joe, what is the difference between continuous compounding and annual compounding?
But if I recall correctly, so continuous compounding is you basically assume the interest rate is compounding with infinite frequency. So
right.
But in practice, I think in practice it's not. I think banks usually, so I think probably most frequently would be a daily. So every day your principal is the interest that you earn on a daily basis is added to your principal. So you also earn interests on whatever you earn as interest previously.
Right. And so let's go and talk a little bit about the formula for continuous compounding. So it's a little bit different. So the way you compute like the value of your the future value of your asset with continuous compounding is that you take the principal and you multiply it by e, which is a constant, to the power of RC, where RC is the continuously. It's a very difficult word. Compounded. Continuously compounded. Right. There we go. So that's how we do that. And again, we want to know what did I, right? We want to know the rate with continuous compounding. And what we know already is that p times e to the power of RC is equal to p times 1 plus RQ over m times m, right?
Yep.
So again, these two cancel out just because we divide both sides by p. And then if we want to isolate RC, what can we do, Jojo?
you need to take the natural logarithm of both sides, so which will be ln.
That's correct. Let's take the natural logarithm of both sides. 1 plus rq to the power of divided by m. This is to the power of m. So m is within the parenthesis. So ln of e to the power over c, that just leaves us with our c. And ln, oh, there's a funny mathematical property about this guy, right? So we know that the logarithm of a to the power of b is equal to what?
Can be b times logarithm of a.
That's correct. That's correct. That's a nice property of logarithm. So in this case, b is our m. So we can take this guy and put it here, so that we have m times ln of 1 plus rq over m. So far, so good?
Yeah, all good.
No babies forgotten anywhere?
No.
No, that's good. So maybe let's do that in code as well.
Yeah, sure.
Now that you know the drill, let's write our function. So compute continuous oh god, it's a very very confusing word. Compute continuous rate. So still, let me think.
We don't have an equivalent word of a continuous in French, do we? Continuous.
I don't know. I've always studied financial maths in English, so I really don't know. It must exist. It must exist.
Or just not commonly used.
Yeah. So again, we need our nominal rate. Our nominal rate, and then our compounding frequency. And we're going to return the continuous rate. And in order to compute the continuous rate, what did we say? We said that, you tell me the formula.
It's m times net ln. So I guess you will need to import a Python library.
That's true. That's true. Either the math module or the NumPy module. So np log times 1 plus
our nominal in this case over m divided by n.
Our nominal over m. Let's see. And let's try and do the same. And maybe I will print again. Print continuous rate. That's going to be equal to whoa. There we go, and this is we can code. Do you think we have it all right, Jojo?
Yes. Apart from that, do we still need to import NumPy, right? It's giving you
all right, because if I try to do this, So there's a couple of issues here. There's a couple of issues. So the first one is that our nominal is not defined because I need to put the actual number, which is 0.07, and this is 4. So this is one issue. And then the other thing that you're mentioning is that I need to import the module that I'm calling here to use the function. So let's do that. Let's import numpy as np. There we go.
Yeah.
And let's see now. And yes. And the numbers look pretty much right. And I was wondering how much time has passed since we started, just because I don't want to kill our audience. Okay. So is there any idea that you have that we could use to improve this code?
No, not as far as I'm concerned.
All right, let me try to make a suggestion to make things a little bit more funny. What if we created a function that takes whether we want the annual rate, the effective annual rate, or the continuous rate? Yeah.
Yeah.
So basically, we would need to write a function that takes as an argument the info of whether we want some annual compounding frequency or some continuous compounding frequency. That would be a nice thing, wouldn't it?
Yeah. So you mean we can introduce if functions in if statements inside the function. So we simply use one single function to calculate both, as long as the user inform the function about either annual or continuous compound rate they want, right?
That's exactly the case. So it will look pretty similar in the beginning. So it will be a function, compute rate, and it will always take the nominal rate as argument. It will always take the frequency, but it will also take the compounding frequency. Frequency, which, let's say that by default, it will be annual by default. So if it's not specified, it will be annual. So, or let's not specify it first, and let's see later what happens. Let's do this. So basically, we always want to return a rate, but you were mentioning if statements. Why were you mentioning that?
Well, because in our case, then there would be two scenarios, right? So either annual or continuous compound. Then just like we have two different formula to calculate the rate.
Yeah, that's correct. So basically, if the compounding frequency is annual, then we will compute the rate in some way.
Yeah.
Whereas if the compounding frequency is continuous. Wow, I wrote it correct on the first attempt. So if it's continuous, then the formula will be another one.
Yes. Yeah.
And otherwise, if it's neither continuous nor annual, then we want to throw
error message.
Yeah, let's let's throw an error message, value error. That's going to be invalid compounding frequency. That's what it's going to be. All right. And so we did this already. Please remind me what I need to do here for the annual compounding frequency.
So it would be 1 plus R nominal over M to the power of M minus 1.
Okay, so this is in the case of the annual compounding, and in the case of the continuous compounding,
M times Ln, so non-pi dot Ln log 1 plus R nominal over M.
okay, and then let's print a couple of things here. Let's print both the compounding frequency and let's print the rate as well. Print the rate. There we go. Do you think we're good to go? We need to test now if it works.
Yeah.
So
I think
let's
comment. Good to go. Let's try.
Let's comment these lines and see if we have it all right. So let's start with the first example. So let's try to compute the rate and our nominal. So it's 0.7. Compounding frequency is 4. And sorry, and yeah, so M, I called M the compounding frequency, but it's the number of periods per year. And this is a little bit, yeah, the wording is a little bit confusing. Sorry about that. But anyway, we want to compound annually. Let's compound annually. So let's see if we get the same result that we got earlier. What do you say?
It's the same. It's the same.
It's the same. All right. So let's try another thing now.
Continuous.
Let's try what happens when we do continuous. Continuous. Here we go. Let's print the continuous rate from before. Well, this is the one from before, and this is the one from now. Yeah. So it seems very good. And let's try what happens if we do the same thing, but let's say that for any reason we forget to specify, let's say that we forget to specify the compounding frequency. We get an error because it's missing the compounding frequency. So one thing that we can do is to set it as a default argument and say that if we don't mention anything, then it's annual. Let's try and do that. What do you say? To me, it seems that it worked.
Yeah.
And let's say that we do something that we didn't that we didn't define, let's say that we do quarterly, let's see what happens. We're getting this invalid confounding frequency. And why is that happening, Joël?
Because the quarterly has never been defined in our function. So the function, the Python itself, it doesn't recognize the value we're putting in this function, so it gets confused. So how can we solve it?
Oh, well, I think we did as much as we could do in this case. Like, for the scope of this exercise, we solved the exercise. We also dealt with the error, so that we raised an error whenever there is something wrong that happens. So we dealt with the error. We are raising an error, and whenever we write some compounding frequency that is not dealt with, then we get the error message that we prepared. There is a way to generalize this function further, and it's gonna probably be the topic of our next webinar. So I think we dealt with what I wanted to deal with today. And now that you're here, Jojo, I'd love to take advantage of the opportunity of asking you a few questions about your career path, just for our students. I mean, the main public is students from the first year of masters at Schema Business School, but we are making this public for everyone to see, and it might be interesting for people who want to break into a finance career like yours. It would be nice to know a little bit how it started, because it wasn't super easy at the beginning, right? It came in ebbs and flows, didn't it?
Yeah, it wasn't pleasant at all.
So I remember it very well, because we were roomies back then. We were roommates, flatmates back then. So it all started with a role at Bank of China, if I remember correctly.
Yes. And it took me I don't know, nearly 4 months to get it right.
Yeah, but you got it.
Yeah, eventually I got it. I mean, it wasn't easy at the very beginning, but once you are on the right path, and then you can just keep going for what you aim for. And yeah, I mean, nothing is impossible, right?
Yeah, I mean, both of us sent countless resumes here and there, and then after Bank of China, a very good opportunity came. Before we move to the next opportunity, what were you doing in a nutshell at Bank of China? You were doing credit analysis, weren't you?
Yeah, I was just taking the balance sheets from different companies that they are applying for credit, and getting those numbers, and it's basically the way to assess the credit risk, right? There's nothing too complicated.
Yeah, and then just right after that, you got another role at Société Générale, right? Why don't you tell a little bit about that? What kind of things you were doing there?
I was working at SocGen private banking sector, so where I was a structured products consultant advisor. So I basically assist with all kinds of daily tasks, preparing term sheets and preparing the weekly summaries, etc. It was very stressful, the internship, but I did learn a lot during that 6 months. Was a very good experience for me.
And that set the stage for the next role, which was probably, I mean, that was your first permanent contract, if I remember correctly, and it was a kind of a fancy role. I mean, it has always looked fancy to me. You always downplaying it a little bit, but I found it was a very fancy role at Web Traders.
Yeah, well, I mean, yeah, probably for all students in FMI master, I think being a prop trader would be most likely one of the most interesting job to have, right? So, but I mean, it was. I was. I mean, my career at Web Traders could be split into parts. In the first 3 years, roughly, I was just doing Delta One, so basically doing a lot of relative value spread trading and try to do arbitrage. Just nothing about high frequency trading. Was more medium and low frequency stuff. And then I moved to the option market making desk, doing single stock option market maker. Yeah, I mean, learning knowledge about options is a lot of fun, but it's also quite complicated to deal with, manage risk, etc. But it was very fun.
Yeah, because there's a lot of variables involved, right?
Yeah, especially during the COVID period back in March 2020, and it was really hectic in the market, and it was super volatile. Also, the fact that during Trump's presidency, there was some extra volatility added in the market, and in general, like every now and then, you see Trump tweeting something, and you can see the markets reacted, and that's fine. I mean, low volatility in general is kind of hard to make money, but I mean, you actually want to have moves, but yeah, I mean, you got to be right, but it can be wrong as well, and then it can hurt when you have big positions and the market moves against you. But yeah, doing prop trading is probably the most challenging, or at least by far, is the most challenging job that I ever had.
Yeah, and I think it was not only the most challenging job to have, but also probably the most challenging job to get, because the selection process was really selective, wasn't it?
Yeah, I guess it was. I believe they were like a few hundred at least. I don't know, probably close to 1,000 CVs sent to for. Well, I mean, the vacancy was about two guys in Delta One desk and one guy for option market making. And on a selection day, on the open day, we had an open day at Web Traders, and then they were, I believe, they were about 20-ish persons invited to participate in the event. And during the way, there was half of us were actually dropped over the process, and it was I mean, we spent full days there to pass different rounds of the interviews, and there was just different kinds. Like you have a numerical test, you're gonna do a gaming, and then there's an interview with the business manager and with HR, with the senior traders. So yeah, but it was interesting. I mean, you gotta be practicing most time if you really aim for such a job, and get ready when you can.
Yeah, and what do you think? I mean, why did they pick you? Why do you think they picked you? Do you remember?
I mean,
Do you remember how you prepared for that kind of roles?
well, I mean, the thing is, I didn't quite know what to expect during the interview. I was mainly just doing some numerical tests online, because there are many websites where we can practice numerical calculation. It's more about mental calculation, so yeah, you got to be fast and accurate. And for the rest, I didn't quite prepare. Oh, I mean, I did review a lot of what we learned during our master, but was hardly raised those questions, because I think personalities is something a prop trading house values the most rather than your knowledge. I mean, you get a master's degree, and it basically proves that your knowledge level is quite enough to fit in the job, but it's more important for the company to understand your characters. right? So
Yeah.
I do recall a very interesting question that they brought up was they were asking, what if you do a very bad trade and you lose tons of money? How would you feel? How would you deal with it? And my answer was that, I mean, if I made a mistake, I just try to learn from it and don't get too sticky to what happened. Just like look ahead and just move forward. As long as you keep doing the right trades and minimize the losing trades that you do, eventually your P&L is positive, right? That's the ultimate goal of being a trader.
It sounds easier said than done, isn't it?
Yeah, absolutely.
And
But
so this
never be afraid of with making mistakes, and because those are very often very valuable things you can learn from.
Indeed. And this is in terms of soft skills, but I'm pretty sure that, I mean, I don't think they stressed a lot on theory, but I'm pretty sure they were valuing a lot your mental calculation ability.
Yeah, I think I did pretty well. I mean, I didn't finish. I think I only finished two-thirds of it, but I think I was good enough. I believe they told me I was the top three. I don't remember exactly which rank was it. It was exactly, but yeah, I did pretty well in the mental calculation.
And I remember you were a strong mental calculator. I think by training, I believe that mental calculation is kind of emphasized in the Chinese curriculum when you do. I don't know if middle school or high school, but anyway, you get out of school and you're pretty good at mental calculation. But you also prepared for it. I mean, you did a lot of. I remember you did. We were together here in Antibes, I remember, and you were doing lots of mental calculation exercises.
Yeah, I mean, you have to, and at least like when you feel more comfortable being mentally prepared, and you're just gonna perform better during the real test, right?
Yeah. So would it be accurate to say that it was a little bit of talent and a lot of work?
Yeah, absolutely.
Very good. This sounds like perfect parting words. Thank you, Joël, for your availability to participate in this session that will be part of the curriculum for our successors, the students from the program that we graduated from a few years ago. So thank you for participating. And
thank you.
Yeah.
I'm glad to be of help for our future alumni, and I hope everyone could ace in their master.
I hope that too. I will do whatever I can to do my part. Thank you for doing your part, and let's hopefully meet again in some next episode.
Yeah, sure. Thank you for having me.
Thank you.